two definitions that we are going to talk about today is an inscribed angle. That is an angle whose vertex is on the circle, okay? Now, I'm going to put it up on the board, and I'll show you the picture here in just a minute. An inscribed angle is an angle whose vertex is on the circle. So, like, this is A, this is B, this is C. This angle here is what we call an inscribed angle. The vertex of the angle is actually on the circle. What is this kind of angle called? No. Well, I mean, it is acute, yes, but nope. Where is its vertex? At the center. So therefore, it's called a central angle. Yes. So there's the difference between the two. Okay. We also learned a while back about central angles and their arcs. What did we say about the measures of the angle and their arc if it's a central? They're equal, okay? We're going to learn something a little bit different about our inscribed angles. The next definition is the intersected arc, okay? That is the arc who is on the inside of the two sides of your angle, okay? So if my angle A here is my inscribed angle, what is my intercepted arc? Arc BC. Okay, so that's what we mean by an intercepted arc. That is the arc on the interior of the angle whose endpoints are on the angle. The endpoints are B and C. They are inside my angle. And we're going to learn something about the inscribed angle and its intercepted arc here in just a minute. Is everybody ready to draw the picture? I'm trying.
I'm not ready. Yeah.
All right. So there's still the definition for intercepted arc. There is a picture. It's a little bit different than the one I drew on the board. And what you need to make sure you write down and memorize is this right here. That's how we find the measure of an inscribed angle. I'll give you a minute to draw your circle and then I'll explain it again. No. The reference chart is going to look exactly like what you used last week. It is not my decision to give, so that's made up by the state and the people who make the tests. So, okay, name the inscribed angle. What is my angle whose vertex is on the circle here? Okay, so angle ABC, I can call it that. Could I also just call it angle B? Is there just one angle at point B? Yes, so we could either call it angle ABC or angle B, or technically could I also call it CBA? Yeah, B is still in the middle. And then the intercepted arc, what arc is in between the edges of my angle? AC. So arc AC is my intercepted arc. And then that highlighted portion there is telling us how to find the measure of the angle. The measure of this angle B right here is going to be half of whatever that arc is. So for example, if that arc is 100, what would the angle be? It would be 50, okay? Or I could even go backwards. I could say if the angle is 80, what would the arc be? 160, it'd be double it, right? Okay. Central angles are equal to their arc. Inscribed angles are half of their arc. Okay, the ones that are at the center, like that one over there, are equal to their arc. The inscribed, where it is on the circle, is half of it. Say that one more time. No, it just has to do with, this one goes further through my circle and it's going to be smaller. This one just kind of stops here so it's able to get the same degrees. All right, is everybody ready? Kylan, did you have a question? Okay. All right. Take a minute. I'm going to move it up in just a second, but I want to read this corollary. It says, if two inscribed angles intersect the same arc, then they are congruent. Okay? So you have technically 4 angles in this picture, if I can get it to move. Okay, you have angle A, you have angle B, you have angle C, and you have angle D, yes? Okay, so I'm going to outline angle A. What arc does it intercept? DC, right? Does everybody see that?
Yes.
All right, I'm going to highlight angle B. What arc does it intercept? DC. So do you see how angle A and angle B cut off the same arc? So that means those two angles are going to be the same measure. So angle A is going to be congruent to which angle? Angle B. Okay. And then we can look at the other two. If I highlight angle D, what arc does it cut off? AB. And then if I highlight angle C, it also cuts off arc AB. So angle D is going to be congruent to angle C. Okay, they have the same intercepted arc, which means the angles are going to be the same. They're going to be half of whatever that intercepted arc is. Okay, it looks confusing because you got a bunch of lines in there, but if you just focus on the one angle, if you need to highlight, you can highlight. All right, here's another corollary. Take a minute and write it. Uh-oh, there we go. If the angle intercepts a semicircle, how much is a semicircle? Half of a circle, which is 180. And if an inscribed angle is half of 180, how much would that be? 90, which makes it a right angle. Okay, so if we're looking at, does everybody see the angle that's inscribed in my semicircle? Do you see how that angle touches the ends of my diameter? It touches A and it touches B. So that means its arc, this inscribed arc, is half of my circle. So that's 180, which means angle C is how many degrees? Well, technically, yes. Okay. Because segment AB is my diameter, it goes through my circle, that cuts my circle in half. So because angle C touches at the ends of that diameter, then the arc is 180 degrees, so the angle would be half of that, which makes it 90. Okay? That's weird. Here's another one. Basically, it says the opposite angles of an inscribed quadrilateral are supplementary. What does supplementary mean?
No, is it like
they add up to be 180, okay? So what's opposite angle A? Angle C. And if angle A is 60, what would angle C have to be? 120. Okay, so I can write that down. 60 plus 120 gives me 180. Opposite angles are supplementary. Yes? What's opposite angle D? B. And if D is 110, then B is 70. Okay. Shh. Opposite angles, those are the ones that are across the quadrilateral from each other, are supplementary. Okay, supplementary means they have to add up to be 180. Because D was 110, I just did 180 minus 110, and that gave me the 70. Does that make sense? Okay, now watch this. This is best to watch my highlighter. Arc BCD. Okay, arc BCD. So we start at B, we go through C, and then we get to D, yes? What I have to know is what angle cuts that off. Is everybody watching? Not the phone, but my TV? Okay. Do you see how that arc is the edges of this angle right here?
Yes.
Okay. So what is angle A? 60, which means that arc is going to have to be 120 because we know inscribed angles are half of their arc. So if I have the angle measure, I just double it, and my arc is going to be 120. It has nothing to do with angle C. It has to do with angle A. All right? And then the other arc they are looking for is BAD. Okay, start at B, go through A into D. So look at the angle that cuts that arc off. What's the angle that cuts it off? Okay. So if C is 120, then what is BAD going to be?
I think it's 240. Yeah.
240. And does BCD and BAD add up to be 360 because that was my whole circle?
Yeah.
Even though it doesn't look like it looks more like they're about the same, right? But we can't go off of what they look like. We go off of what our numbers say. Does that kind of make a little bit of sense? What does not make sense? So you're talking about my arcs. You don't know how I got the arcs? Okay.
Can you say you got B again?
Yes. Look at B. What is B? Hush. What is B across from?
110.
Okay. So 110 and 70, they have to add up to be 180. So what I did was I just said 180 minus 110, which gave me 70. Because that's what this says. Opposite angles are supplementary. All right, those of you who are confused with how I got my arcs, let's pay attention again. BCD, okay, I'm going to highlight BCD. BCD is from here to here. So the angle that cuts that arc off, you got to go to the edges of the arc and follow the lines. Okay. That is an inscribed angle because its vertex is on the circle. We learned just a few minutes ago in one of our first things that we wrote down was that an inscribed angle is equal to half of its arc. What is 60 half of? 120. So that's why we said BCD was 120. Does that make a little bit of sense? And then we can do the same thing with the other one. Okay, arc BAD, we go through B to A to D. So we're going to look at what touches the edges, form that angle. And then again, what is 120 half of? 240, you just double it, right? That's how we're doing those. All right, try those.
Okay.
You especially who are struggling, yes? Everybody listening. Look at your pictures, okay? This arc right here is how many degrees? 140. And this arc is 120, which is basically the entire circle except for that top part, correct? So can we figure out what this top is? Okay, how many degrees is the circle? All right, so if we add 120 and 140, that gives me 260, correct? And then if I take that away from 360, that's 100. So this arc is 100 degrees. That angle is how much of it? Half. Yeah, so half of 100 is 50. Okay? It'll be similar to this. With number 2, there are technically a couple of different ways we can go about this, but what shape is inscribed in my circle? A triangle, and I have 2 out of my 3 angles of my triangle, yes? The arc that I want is this arc right here, which is coming from this angle, correct? Can I figure out what that angle is? Okay. We would add the 2 angles that we have, 50 and 70. Okay, and then I take that from 180, right? Which gives me 60. So that angle is 60, which means the arc is going to be 120. Another way, just in case that's not how you saw it, what you could do, listen. What you could do is if this angle is 70, what would its arc be? 140. Okay. See the angle I highlighted? And then if I looked at the other angle, if this angle is 50, what would its arc be? 100. So then I could do 140 plus 100, which would give me 240, and then I would subtract that from my... It's just another alternative. It depends on what you see. Some people see things differently. Either way, did I not get the same thing for that? Yeah. No, that's not it. The easier way is finding the angle from the triangle and then doubling it to get the arc, okay? But I'm just trying to show you alternate methods because some people are rude and talking while I'm talking. And some people see things differently, right, Jerry? Okay, so I'm just trying to give you different ways to look at things. Are you ready? Okay. Try these. So first of all, one of our corollaries talked about an angle being inscribed in a semicircle. If I look at this angle, are its end points on the edges of my diameter? Which means that's what kind of angle? Oh, right. So now I have 2 out of my 3 angles, right, of a triangle. So 60, 90 gives me what? 150. We subtract that from 180, or we could just remember that 60 goes with 30. So if that angle is 30, what is its arc going to be? 60. We double the arc if we have the, or double the angle to get the arc. Does that make sense? Okay. Another corollary talked about, let's look at our angle, our x plus 20. That cuts off, whoops, that didn't go very far, or didn't go the right way. That cuts off this top arc, right? That doesn't have any letters to it. But if I look at the angle 2x, does it also cut off that top arc? So what do we know about those 2 angles then? They're congruent. So I'm going to take that x plus 20 and I'm going to set it equal to 2x, right? And I solve for x and I get 20.
What if it's not?
It will be if they cut off the same arc. If not, I would have to give you some other information to be able to solve it.
You said I couldn't keep the shirt.
Well, yeah, you
It wasn't, because when I looked at it, I thought it was like
The segment.
it was in the triangle.
Yeah. All right.
you should have paid her.
Okay, try these 2, and then we'll take a look at our last theorem for today, and then we'll talk about what we need. So what is this angle going to be up here? It's a right angle because it is inscribed in a semicircle. And so then to find x, can I just do 3x plus 90 plus x plus 10 and have it equal to 180? So that's going to be 4x plus 100 equals 180. So therefore 4x is going to equal 80. So what is x going to be? 20. Okay. Now, for 6, I have a lot of people asking what b is. Technically, it really doesn't even matter. What did we learn about angles that are opposite in an inscribed quadrilateral? They are supplementary. What pair of opposite angles do I have in this one? A and C. So I can take angle A, 4x plus 40, plus angle C, which is 6x, and have it equal 180. Combine my like terms. Subtract my 40 over. And x is going to equal 14. But then it does actually ask you to go on and find all of those angles. So if I wanted to do that, what would I just have to do after that? Just plug it in. All right, so let's see. 4 times 14 is 56 plus 4, which is going to be 96. 40 is what I meant to say. 56 plus 40 is 96. Okay. 6 times 14 is 84. 5 times 14 is 70. So what would B be? 110. Yep. Okay. So all we're doing is using each one of these corollaries that we've discussed. We do have one theorem that you need to talk about. Yes, another one. And then we will quickly talk about so the theorem basically says an angle that is formed by a chord in this picture, which one of those is a chord? AB, okay, an angle formed by a chord and a tangent. Which one is our tangent? BC. It says that angle is going to be half of its arc. Okay, so this angle B that's formed by that chord and that tangent is half of the arc that it cuts off. So how much is its arc? Well, the arc is 160, so what would angle ABC be? It would be 80. So basically, it's just like an inscribed angle. It just looks different. An inscribed angle is made of two chords. This one is made up of a chord and a tangent, but is still half of its arc.
Yes.
Does that make sense? Okay.